Welcome back, friends. Today we are going to solve very famous interview problem that is asked in many big tech companies such as Amazon, Microsoft, Facebook, and a lot of other companies. So let's solve today the problem 120 of LintCode word ladder. So if you haven't already subscribed to my channel, please subscribe to my channel now. My channel helps people who are preparing for Java J2 interviews as well as coding interviews. It has a lot of good playlist that will help you in your coding preparation as well as Java J2 frequently asked questions and how to answer them. So if you are someone who is preparing for coding in person or telephonic interviews in Java, then please subscribe to the channel. So let's go through the details of the problem first, and then we will go into example, and then we will propose a solution how we are going to solve this problem. So given two words start and end and a dictionary, find the shortest transformation sequence from start to end. Output the length of the sequence. Transformation rule such that only one letter can be changed at a time. Each intermediate word must exist in the dictionary. Start and end words do not need to appear in the dictionary. And then they have given us some more information. Return 0 if there is no such transformation sequence. All words have same length. All words contain only lowercase alphabetic characters. You can assume that though no duplicates in dictionary. You may assume begin word and end word are non-empty and are not the same, and length of the dictionary is less than 5000 and length of start is less than 5. So those are the more informative things they have given, and they have given us these examples. So let's take this example 2 over here, and we will see how we can solve this problem. So so as I said, this is a very important problem. It's asked in Facebook, Amazon, Microsoft. So please make sure you understand this problem. So let's look into this problem. So start word is given to us called as hit, right? And we have to reach to the end word, which is cog, right? So how we can do, like we can do some kind of a transformation, but transformation we can do only one character in this word. For example, one transformation that is possible from hit can be, it can be, I can just change that I to O, right? So hit to hot, this is one kind of because one character we are allowed to change, right? So we have to find out which transformation we can make. So we have to find out shortest path to reach from hit to cog word, right? So and we can only use the dictionary words, right? The word should present in dictionary. For example, if I make a transformation where I change the H is there, but I change that H I to A and T is as it is, right? So hit to hat, so that one is not possible because the hat word is not there in the dictionary, right? So we have to find out a word that is there in the dictionary, so we can go to the next step of transformation, right? So what we are going to do to find out what next word can be in the transformation is how we will be doing it. So I'll show you that. So we will take the word that is given to us right now, like the beginning of the word, like so hit is the source word that we have right now. So what we will do is, in English alphabets we have A to Z, there are 26 characters, right? So we will try to change this every letter to A to from A to Z, right? So basically how what I mean to say is hit is given to us, then we will try to change H first, right? We will try to change H with A, then B, then like this we will go until Z, right? Like this we will do. Okay, and once that is done, we will keep finding if that word is present in our dictionary, right? If the dictionary contains a word, for example, then we will put that as a neighbor of hit, basically, right? So hit will have some neighbors, right? So we are trying to find out which are the neighboring words for word hit, basically. So during this process, so we will be done with H, then we will do it with I, right? So again, we for I we will start with a replacement from a b until z, right? All the way until z we will go, and after that we will again do it the same thing for t word, character t. Again we will replace it with a b c d e f until z, right? And at the same time we will keep looking if the word is present in the dictionary. So during this, so let me just now remove this. So now you got it, right? One by one we will take a letter and we will replace it with a b c d to z for all the letters in the word. So let me take this out now so I can write it again there. Okay, so now as you can see during this process, what neighboring word we will find now for heat is hot. Hot is one of the word, right, that we can find, because hot can be available in the dictionary. So we can word take hot is there from heat. So our first sequence, that is the only word that is present, so that is the only neighboring word. So we will use a BFS technique, right? BFS we will use BFS, and we will put the neighboring words into the queue, right? So let's say this is our queue here. So this is our queue. So we will first put heat is already there, right? Heat is there. So from heat we will put now the next word. Heat we will take out. Now we are converting this heat. Now we found another word which is neighboring for heat, which is hot, and hot is there in the dictionary here, right? So now from heat to hot we already transferred from heat to hot. Now we will do the same thing with word hot, right? So now let's just take word hot here. So now again we will try to find out which are the neighboring word for word hot, right? Again we will do the same thing. We will take h character and we will replace this character h from a to z. Then we will take o character, we will replace the o character from a to z, and then we will take t character and we will replace from a to z. And at the same time we will keep finding if that word, what new word we are preparing, is there in this dictionary. So at that time we will find dot, right? Dot is there, so we will put a dot here basically into our, and we will keep putting distance also, right? So now first the heat distance is 1. Now hot distance become 2, right? And then from hot we will get a dot now, right? Dot is another word with a distance 3, right? Because dot is neighbor of hot basically. So as you can see, dot is neighbor of hot, so we will put dot into our queue. And then another word we will find is a lot, right? Lot is also there, so dot is there, and lot sorry, so here, right, dot is there, this dot is there into the dictionary, and lot is also there. So both dot and lot, we found two neighbors for hot, which is dot and lot, and we will put both of them, but both will have distance 3. So as you can see, we put dot here into the queue with a distance 3, and we put a lot here into the queue. Again distance is same, right? 3 basically. And now how BFS work is we keep popping out the things, right, from each level basically. So now we already took out hot. Now we will take out lot and dot we will take out, right, from the queue. So I am just writing here now. So lot and dot we take out from queue, and then we will try to find out its neighbor. So dot's neighbor is dog. Dog is a neighbor of dot, right? Because only one word, one character t you can replace with g, and dot becomes dog. So dog can be a next word with a distance is 4 now, right? Because that is 3 plus 1 is 4. And for lot, the next neighbor can be log, right? For lot, next neighbor can be log, because if you change the t, then it becomes g basically here. So log is neighbor. Again distance is like 4 here, because as you can see, right? Now again we will put dot and log into the queue. This dog and log into the queue. Dot and lot we have removed from the queue when we have processed that level, right? We are going level by level, because that is how the BFS work, right? So basically what I mean to say, I'll just show you here what level by level means. So this is one level, right? This is one level. Then hot is one another level, which is level 2. Then dot and lot, this as I'm showing you here, this is another level which is level 3. Then this one is level 4, and the last one is level 5, right? So these are levels of BFS, how it gets processed, right? So I'll just take it out now. So now we are at dog and log. Basically now we are processing this level 4. So at this time, when we replace D with C, we get the word cog, right? So cog is the our answer word. So and here also when you convert like L with a C, then it becomes cog, right? Here also it becomes cog, but with distance 5. So as soon as we see any new word with a distance new word we have reached, then as we will just basically return break from that. Basically we found a shortest sequence. So that's how the BFS work. So as you can see, the answer will be 5, right? 5 is the shortest sequence you can find, basically like this. So here if you look, the output is 5. They have given us explanation like this. So here is the transformation. So the same transformation I was showing you. So transformation can be reached in any of these way. These both ways it can be reached. So whatever reaches first, we will take that answer and we will just return that as our answer, right? So at the same time we will keep a like we will be using in Java a map, right? Map of string comma integer. Why string comma integer? Because we want to map every word with the distance we have traveled. For example, hot is distance 2, so we will put an entry into the map like hot 2. Then dot is distance 3 we have traveled, so we will put a entry into the map dot 3, right? Dog means we will put dog 4 because that is 4 distance we have traveled. Cog means cog 5 distance we have traveled, so we will maintain that using a map in Java. So this is the general approach how to solve the word ladder problem. So let us look into the implementation now. So so I just divided like into couple of functions, so it's become easier to understand. So this is the main function that we have been given. So first we will make sure that our dictionary, if it is empty, then we cannot make any transformation, right? Then we will just return 0 in that case. Otherwise we will be adding our end word into the dictionary. We added, right, end word cog, because cog will be required then for our approach to work, right? Because every time we are finding a word, we will have to check it in the dictionary, that word should exist. So we added cog into the dictionary, for example here. And then we call our BFS function here, right? BFS is a function that we are using here. So we just passed a start word, end word, and the dictionary, that right, that is given to us. This is the dictionary, for example. And then we create a queue here, which is a array dq. It's just a queue basically of Java. And then we created a map of string comma integer, right? Because we want to map this every word and distance, so that is why we need the map for that purpose. And after that we are going to offer the start word, basically hit into the queue, right? And a distance we want to put is in the beginning is 1, correct? Okay, and then we will put the start word, and distance means basically hit is the start word, distance is 1, right? Here in the map we will put hit here in the beginning, and distance will be 1, right? Distance will be 1 here. So that's what we are doing now. Our BFS starts here, basically in the while loop. Basically our BFS starts in a loop, right? So here we will always increment the distance first, because we are processing levels that I showed you here, right? First level 1 2 3 4 5. So we want to make sure that we are capturing the distance, because that is what we want to return at the end. And then we will get the how many is the size of the queue, because that is how many elements we have to process, right? So we will first read that size, and then we will keep polling the elements from the queue here word by word. And then we will check if we have reached the end word, right? If we already reached the end word, then we have to just return the distance, basically means basically we our program is ending here when once we find the ending word. If that is not the case, what we will do is we will try to find out the neighbors, and neighbors which are actually so let me show you the neighbors method here. The neighbors method is what it does is, as I said, it will take this, let's say we are at hit word, right? Hit. So what neighbors method does is it takes each character by character, and it will replace it from A to Z, right? H it will replace from A to Z, I it will replace from A to Z, T it will replace by A to Z, and then it will keep checking if that word is present in the dictionary. So that is what we are doing in the find neighbors method. So it will just create a list of neighbors. It will it will replace from A to Z every character in the given word, and whenever it finds the word in the dictionary, then we will just add it, that is our valid neighbor, right? So that's what we are doing here. So this one is just for the, I was just printing like the debugging. So ultimately it does for all the characters this replacing from A to Z, and when it's trying to find, and whenever it finds in dictionary, it will add into neighbors list and returns the neighbors list here, right? So we get the neighbors list here, and we are doing a for loop now with the neighbors, right? Because we want to now we found what are the neighbors, we want to do the BFS again, right? So we have to offer those nodes, offer those words into the queue, right? So we are doing it here. So we are adding those neighboring words here into the queue, and we are also adding that neighboring words distance also into the queue, right? So this distance, basically neighboring word hot distance 2, then next time it will add dot distance 3, like that basically. So that's what it is doing, and it will try to like loop through in the BFS, right? And so this is another auxiliary method that I wrote, like replace, where it will take it will replace a character, right? Character by character, basically this one, right? Hit H will be replaced by A, then B, then C, then it will go until Z, right? Z. So that's what it is doing. So this one, this BFS while loop will continue. So if we can reach a word, then it will always keep checking here in each level, right? That we are reaching the ending word. If we are finding a ending word, we have to just return the m dot get word, means from map we will just do a get, right? For that, for example, cog, right? We will just do get and we will get 5, right? And that's what we wanted to return. If it doesn't happen in the BFS, means we cannot reach that word, then in that case it will return 0. So that is how the word ladder problem you can solve it. So let us just take this same example that is given to us and just make sure our solution is working fine. So as you can see, we got a 5 right here, 5. So so this is how the like word ladder problem works. So if you just want to see how the map is getting formed, I will just can print the map for you here, so I can show you how the map looks like, right? Every time it goes here. So let me just show you here. I'll just write one system out so you will see how the map gets formed. Okay. So now here, as you can see how the map is getting formed. See, first we started with hit, then hit becomes hot. So we went to 2. Now after that we hot becomes lot, and lot and dot we added, right? 3. Lot and dot we added as a 3. Then after that we added log as a 4, right? Log and dog as a 4 basically, right? And after that here you can see that we reached the last one, right? 5, cog. And then we are going to break because we are now finding the ending word here. So see how the, like, that is how the BFS work. It starts with the source word hit, and ultimately it reaches the destination word, which is cog, right? So this is how the transformation will be basically, correct? So this is how it works, the word ladder problem. If you give some kind of a, like, let's say if I give a wrong word, bag, let's say, then this I cannot reach, so it should give us 0. So as you can see, the output is coming 0 because this is a negative test case basically, where we are giving a word that cannot be reached. so it will give us 0, right? So this is the way you can solve the word ladder problem using BFS and Q. So we will be just going ahead and submitting our solution now. So our solution got accepted by LintCode, as you can see it here. So this is the way you can solve it, the problem. So make sure you practice, understand this problem. This is asked in Google, Amazon, Facebook. Um, so make sure you understand this problem. Also check out my Leetcode solutions playlist. It has over 100 solved different problems which are asked by big tech companies, like Apple, Google, Microsoft, Facebook, and lot of other, so check out the solutions. It's explained with the examples and Java code, so it will be easier for you to understand how to approach the problem. Also, there are other playlists which are helpful for Java interviews, which discusses frequently asked Java interview questions and answers, and what you can expect during telephonic interviews, how to answer those problems. There are a lot of material, like good material, that will help you if you are appearing for Java interviews. So please go through them. Also, if you find this video helpful, please like it and subscribe it. Your subscription is really important to us, because that is the way the video can reach to more people like you who are preparing for Java J2E interviews. They can watch this video and get help from these videos. So please subscribe for the video, and thanks for watching it.